All right, welcome to class. We are still talking about differentiation. We have seen some other rules, but we still have some to go through. Like, for example, today we are going to look at the quotient rule. Let's start on it. If you're dealing with the quotient rule, we have the general formula that we use. You may be given a function f(x) equals to u with respect to x divided by v with respect to x. This could be the function. So what do we use here when we are talking of the quotient rule? Also, what we need to know about the quotient rule, the meaning of this word quotient. Quotient is a result that is got after dividing two numbers. Let's say you're dividing 10 by 2. The answer that you get as 5 is your quotient. So it is also very important to know that. Now, what does the quotient rule say? To get the derivative of this function, which is f prime of x, this f prime of x is also the same as the dy dx. The general formula that we use here is v du out of dx minus u dv out of dx. Everything is divided by v squared. So when you are given a number, this is the formula that we have to keep applying in most of the numbers we shall be doing. So it is very good to take note of this formula. To understand this better, we shall need to look at an example. Let's talk of example 1. You may be given a question that find the derivative of 2x divided by 4x squared plus 2. Now, in this kind of question, we are supposed to apply the quotient rule. And in our solution, this is what we are supposed to do. We begin by letting u to be equal to the first term. For this case, it is 2x. After letting u equal to the first term, we differentiate this u with respect to x. So we get here du dx. And if you differentiate this one, you recall very well, to differentiate 2x, the answer we get is 2. Because here there is power 1 and the x disappears. So if u is 2x, du dx is equal to 2. So we also let v be equals to the Downer function, which is 4x squared plus 2. Now we are also going to differentiate v with respect to x. So this is dv dx. What do we get here? This 4x squared, when we differentiate these two multiplies here, we shall have 8x. The power reduces by 1. And when we differentiate a constant, which is this 2, we get 0. So dv dx is the same as 8x. Because we don't want to consider that. Now from there, we have to remember our formula. we have to remember the formula that says dy dx is equal to v du dx minus u dv dx. Everything is divided by v squared. So we are going to substitute whatever we have got here in this formula. Let's go to the next step. So we have our v here, which is 4x squared plus 2. This is 4x squared plus 2 times du dx. Du dx is 2. So we are going to multiply this by 2. And we subtract u is 2x. So minus u, which is 2x. We are also going to multiply it by dv dx. dv dx is 8x. So we are going to multiply this by 8x. But everything is divided by v squared. So we get the value of v and we square it. So v is 4x squared plus 2. And we square it. We can now simplify this. We can simplify this and we multiply here. We open this bracket. This is 2 times 4x squared, which gives us 8x squared plus 2 times 2. That is 4. Then we also open the other side. This is 2x times 8x. That will give us 8x squared. So this x and that one raises the power to 2. Everything is out of 4x squared plus 2 power 2. We can simplify that and get our final answer. Because this is a negative 8x squared, this is a positive 8x squared. So this one and this one can cancel out. And we remain up with 4 out of 4x squared plus 2. If we want, you can reduce, but we can stop there. So we take this one as our answer. Let's